Okay, the first component in the UMTS network that we're going to have a look at is the user equipment. Okay, now Ainkaran has already talked about this a little bit in the first lecture, where we've seen user equipments gone from very simple boxes to very complex devices today, and they're continuing to become more and more complex. Now, when you talk about user equipment, you're not just talking about handsets. You could have PC cards that you can put into a PC. You could have a 3G modem that sits on a desktop and connects to your laptop externally. You could have an integrated card. Okay, nowadays most of the new laptops, new high-end laptops that are being sold on the markets have an integrated 3G or UMTS or HSDPA inside it, so you cannot see from outside that it has one. That could be another type of user equipment, and then your current conventional phones and PDAs that can also be wideband CDMA terminals. So whichever terminal or user equipment you look at, the user equipment, as we've seen before, the user equipment communicates with the UTRAN, primarily the node B, through the UU interface. Okay, so, and that's the UU interface is the interface on which wideband CDMA has been implemented. So the user equipment consists of two parts. The first part of the user equipment is the mobile equipment, and the mobile equipment contains all the electronics, the hardware that is used to communicate with the node B. The second part of the user equipment is the USIM, or the SIM card. Now, the SIM card in UMTS is more complex than the SIM card in previous GSM GPRS networks. So apart from holding subscriber identity information, all of the algorithms that is required for authentication and encryption of data is performed using the algorithms in the SIM card. It also stores keys that are necessary for authentication and encryption. Okay, and you also require information, subscription information that is needed at the terminal. So what we have in the user equipment is the USIM and the user terminal, and the interface between these two is referred to as the CU interface, and the user terminal communicates with the node B. This is how a typical a Nokia node B looks like over the UU interface using wideband CDMA. Okay, now when they this slide is probably a couple of years old, but when the phones were still not out, but when they were thinking of coming up with different types of phones for wideband CDMA, and these were some of the concept designs that they had. But some of these phones are now available on the market and have been for some time now. In terms of the terminals, how exactly are the user equipment, the UMTS user equipment different from the GSM ones? Well, all user equipments have different power class categories. So there's power class 1, power class 2, power class 3, and power class 4. Now, if you compare wideband CDMA with GSM, okay, so for example, GSM power class 1 had a maximum of 20 watts, maximum output power of 20 watts, whereas the power class 1 in wideband CDMA is only 2 watts, so about 1/10 of the power that is needed. Okay, now power is very important in wideband CDMA, and we have to make sure that your users transmit at the minimum possible power, because whatever you transmit in UMTS is interference for all the other users. Okay, so you can see that the power levels that you're dealing with in wideband CDMA is much smaller than those that were used in GSM. In terms of the USIM, okay, the USIM, as I told you earlier, the USIM is more complex than the SIM that existed in previous networks. It allows other possibilities, like for every entry you could have 2 name fields. Okay, so for example, if you wanted to keep people's name in both English as well as in, say, Mandarin, you can do that in this USIM card. You can also have multiple phone numbers per entry. So with one entry, you could have their, their mobile number, their home number, their fax number. All of those entries could all be kept in one entry. So you don't have to create multiple entries like you do in the current GSM network. It also supports email addresses. So for every entry, you can also have the email address. So essentially, it gives you more flexibility. And you can also have definable groupings and so forth. And the security that is implemented in USIM is better than the security that existed in GSM and GPRS network. Okay, there's also a mechanism called mutual authentication that is available in the UMTS network that did not exist in the GSM networks. Okay, so we move on to the next component, and possibly the most complex one is the UTRAN. Okay, remember both the UE and the UTRAN are the new network elements, because most of the network elements in the core network are all inherited from the GSM network. Now, if you look inside the UTRAN, the new network elements are the node B and the RNC. Okay, an RNC and the associated node Bs are referred to as an RNS, or a radio network system, similar to the concept of BSS in the GSM world. We've already seen that there's an interface called the IUB interface that communicates between the node B and the RNC, and the IUR interface between the RNC, one RNC and the other RNC, and the RNC communicates with the core network through the IUCS and the IUPS interfaces. Okay, so the UTRAN, as I said, is probably the most complex part of the UMTS network. Okay, it's got to communicate with the user on wideband CDMA. Okay, and it's got to make sure that all of the radio resources that you have are used as efficiently as possible. And it's also the primary transport technology that has been defined for the UTRAN at present is the ATM. So once the information comes from the user on wideband CDMA, the node B has to start putting all of this information that comes on wideband CDMA on the air interface into ATM cells and transmit it on the IUB interface to the RNC. And the RNC in turn sends it either to the circuit switch or packet switch network. So ATM has been designated as the main transport mechanism in UTRAN for the time being. Okay, does anybody know why ATM was selected? So I think quite a few of you are doing the ISN subject, isn't it? What's so fantastic about ATM? Class 2, Class 5, these names ring a bell? What's so fantastic about ATM? Okay, it allows, you can have on the same, it's an integrated network, okay? So you can transmit voice, real-time traffic as well as non-real-time traffic on the same network in the form of ATM cells. And different types of ATM cells will be given higher priority, okay? And switched faster. So real-time traffic can get through an ATM network much more quickly than non-real-time traffic. Okay, so that's primarily the reason that ATM was chosen, because it provides quality of service differentiation. Now we'll see that in the future, ATM will be slowly, as we move more and more towards an IP-based network everywhere, all the way starting from the user to the both circuit, the existing circuit switch network will all become obsolete, and will move towards a complete IP-based network. Then eventually the IP-based transport will become the dominant form of transport from release 5 onwards. Okay, so what else do we know about the UTRAN? Okay, so the UTRAN, as we said, consists of the node B, which does the data flow, whatever it's coming on the air interface, on the UU interface, it converts it into ADM cells and transmits it on the IUB interface. It also performs some important radio resource management function. Then the next element is RNC, which is probably the most important and probably one of the most expensive pieces of equipment in the UMTS network. What has happened is some of the functions that were done in the MSC, in the 2G network, have now been pushed over down to the UTRAN network. So as a result, the RNC is far more complex than its equivalent BSC in the GSM network. So what are the functions that UTRAN performs? Well, it's got to perform radio resource control. So all of the radio resource allocation mechanism is controlled by the UTRAN. Admission control, which is about admitting users. Do we have sufficient resources in our network to admit a particular user? We have congestion control. When your network goes into congestion, what do we do? Okay, do we admit this user, or do we transfer some of the existing users to another network? Maybe if some of the users are on the edge of a cell, why don't we get them handed over to another cell where there's not much congestion happening? Or if the entire network is congested, if there are users who are capable of being transferred to a GSM network, why don't we get them to do a handover from a UMTS network to a GSM network? So all of these functions have to be performed by congestion control. The other thing it might also do is if it has provided certain high-end users high data rates, it might decide to slow down the data rates of individual subscribers. The other thing that the UTRAN has to do, and more specifically the RNC, is it's got to allocate codes. Now remember, in UMTS uses wideband CDMA, which is based on the idea of allocating codes, and we're going to see wideband CDMA in more detail in the next lecture. Code allocation, every user has to be allocated a code, and these codes have to have this property of orthogonality associated with it, and they're all allocated from something called a code tree. So code allocation is another important function that UTRAN performs. Power control, we've already mentioned that power control is an important function that a UMTS network has to perform, because a UMTS network is an interference limited network. Okay, there's only a certain amount of interference that the network can cope with. So you've got to make sure that all users are transmitting at the minimum possible power, because everyone's transmission is interference for the other users. Handover control refers to handing over connections either from one sector to another sector within a cell, or from one cell to another cell, or from one network to another network. So all of these functions have to be performed, and there's also something called macro diversity that UTRAN has to perform. We'll go into some of these functions a little bit more detail when we discuss wideband CDMA next week, but just bear in mind that these are the functions that UTRAN has to perform. So we said that the UTRAN is made up of two parts, the node B. The node B is equivalent to the GSM base station. So everything that's transmitted on the air interface, all radio transmission between the node B and the user are done by the node B. So it's got to take your baseband signal and it's got to modulate it, but before modulation it has to perform a number of different functions before it transmits it. Okay, so what are the important functions? Well, whenever you have transmission across the air interface, you have to do error correction because of the bit error rates on air interface is much higher than in wired links. So to compensate for the errors, you have to have error correction codes, and these error correction functions have to be performed both at the node B as well as in the user equipment at the two ends of the air interface. Rate adaptation. Okay, now there are certain well-defined rates at which you can transmit data on the air interface. So if you are transmitting at a rate that if your data is not at a rate at one of these specified rates, your data has to be adapted to one of these well-defined data rates. So that's called rate adaptation. Spreading and despreading. Okay, whenever a baseband signal has to be spread into the 5 megahertz bandwidth that is associated with wideband CDMA. So that spreading function at the transmitter and the despreading function at the receiver have to be performed by node B. Modulation. Modulation is a technique that's used for transmitting data over large distances, and QPSK modulation is a modulation that's used in node B. Handover. Okay, there are many types of handovers, but the one type of handover is performed when there are handovers within a node B, because a node B could be having many sectors. When there are handovers within sectors associated with one node B, those handover functions are performed by node B. Okay. The other thing that the node B has to do, both the node B as well as the BTS have to do, is you need to know the quality of the radio channel between your base station and the base station. Between the base station and the mobile equipment, the quality of the radio link has to be continuously measured. Okay, so both the node B as well as the user equipment are taking measurements of the transmission link, because remember there are some well-defined patterns that are continuously transmitted on the signaling channels, and these signaling channels are measured, and the data rates, the error rates on the radio channels are measured and recorded and transmitted back to the RNC, and the RNC can then know what is the quality of the radio link between every node B and the corresponding mobile equipment. And then node B also does a little bit of power control. Okay, there's 3 types of power control that are used in UMTS. There's something called outer loop power control, inner loop power control, and open loop power control. So the inner loop power control function is performed by the node B. So the node B transmits something called TPC commands to increase or decrease the transmit power of a mobile. So these functions here are the important functions that a node B has to perform. Okay, so if that's your mobile equipment, and that's your node B, and that's your RNC, that's how an RNC cabinet will look like in real life, and that's how a node B will look like. So you have data. So all of these functions, the functions that I talked about, can be classified into 4 important functions. One is the air interface management, that is managing what's happening across the air interface. Then there's also, the node B also has to transmit in the form of ATM cells all of the data that it is receiving from the user, and that is called cellular transmission management. And then there's also basic O&M processing. Remember, every network element that we had on the diagram that we drew before, all of those network elements communicate back to a network management system. Okay, so if there are alarms on various components, and also different performance, the way the different links are performing, all of those are sent back to a network management system. So all the O&M processing deals with that. So these are the important functions of the node B. How do the node Bs look like? Well, there are different ways you could have node Bs. Essentially, a node B, if you look at a node B, you will have some panel antennas on the top of a tower, and then there'll be cables going down to a piece of equipment. So this is if you go into one of those cabinets at the bottom of those towers, you will find equipment that look very similar to this. They'll have cards for various functions here. There'll be cards for power. There'll be cards for different types of signaling and so forth. And then you have another piece of so these panel antennas, which are usually in 3 sectors. Could be more sectors, but usually 3 sectors, are used for communicating with the users. And then there are also these point-to-point parabolic antennas, usually much smaller in size, that are used for communicating from the RNC, from the node B to the RNC. Okay, so even the link between the node B and the RNC could be a fiber link. It could also be a radio link. Most of the time, radio links are used because when you put something on the ground, people can chop it. If it's copper, people can steal it. So in a lot of places, they use radio links for the link between the node Bs to the RNC. So that's one possibility where you have towers. The other possibility is you could have on the top of a building. Now, when you come by train every day, if you look on a lot of the buildings that you have along the railway line, you will find antenna sites at the corners of the buildings. Okay, so these antennas could be connecting to the base station equipment, which could be in a locked cabinet. Okay, and the equipment could be sitting in there. So that's one possibility. Another possibility is on the side of a building. You could have these node Bs, and these node Bs are usually used for very small cells, okay, because you're trying to keep your antenna as low as possible so that you can create a small, maybe a picocell with it, whereas these ones here are usually at the top of a building, so you're trying to create a larger cell with these kind of antennas. And then as you go towards the bush, as you go away from the city center, you will find more of these kind of situations where you will have a large tower and antennas at the top of it. So base stations can be implemented in different ways. These kind of base stations are becoming less and less, okay, because it's becoming harder and harder. People are getting afraid of these base stations. Okay, they don't want. Nobody wants a base station in their backyard or anywhere near their backyard. So councils are giving less and less permission for people to put up base stations. Okay, so as a result, all of the operators are getting together and trying to use the existing base station sites that they have, trying to share them rather than building new base station sites. Especially in developed countries, this is a problem. In developing countries, I feel it is not that a big problem because, they just go and put base station wherever they want, and they don't give they give two hoots as to what people think. But the world is changing. So the next thing is the radio network controller. So we talked about node B. The next one is the RNC. So what does the RNC do? Okay, now if you look at the functions that the RNC does, the functions are listed below on this slide here. The main functions are what are referred to as radio resource management functions. So power control, handover control, admission control, code allocation, packet scheduling. These are the main functions that the RNC performs. And then it also does something called macro diversity combining, splitting over a number of node Bs. Okay, I'll explain what that is in a few minutes. So these are the important functions that the RNC performs. I explained all of these functions. When I looked at the functions of UTRAN, I explained each one of them, and most of the functions of the UTRAN are performed by the RNC. Okay, now we talked about something called macro diversity. Anybody knows what macro diversity is? There's a concept called macro diversity, and there's also a concept called micro diversity. Okay, two important concepts in the context of wideband CDMA. Anybody knows what they are? Okay, now in wideband CDMA, a mobile can be communicating with a number of base stations simultaneously. Okay, remember in GSM, you only had one link between the mobile and the base station. Okay, and when that link was getting bad, your link gets handed over to another base station. So that is called a hard handover. Okay, so it's you have a complete transfer of the connection. But in wideband CDMA, your mobile may be communicating with a number of base stations simultaneously. Okay, so for example, this mobile here, this mobile that you see in this diagram, is communicating with this node B, and it's also communicating with this node B simultaneously. Okay, so for example, in the uplink, the data that it's transmitting goes to this node B, and it also goes to this node B. And from this node B, it goes to the appropriate RNC, and then the RNC looks at the data that's coming through, and it knows that this particular connection is associated with another RNC, okay, and it sends this data along the IUR interface. So this data that's coming from this user comes up to this RNC. This RNC is referred to as a drift RNC, and the data goes up via the IUR interface to the originating or the main RNC that is controlling this particular user, and that is referred to as the source serving RNC. So at any point in time, you've got the same information that is coming to this RNC on two different paths, and these two different paths could have completely different radio characteristics because this channel here and this channel here are completely independent. Okay, and remember, because these node Bs could also be physically separated, okay, so they could be in complete different directions. So what this RNC is doing is it's comparing the data that it is receiving from on this path, and it is also comparing the data that is coming all the way around on this path, and it is selecting the best data. Okay, and that is referred to as macro diversity. So as you're traveling, maybe you're traveling on a road, at one point in time you could be in the shadow of this base station, in which case the data that you're transmitting on this node B could be the better one. So in that case, the RNC will be selecting that data, and a few seconds later you move back into direct line of sight with this node B, and maybe you go into the shadow of this one. And at that point, the RNC, the only way the RNC knows is it knows from the data bits that it is receiving, okay, and it also has an indication of the channel quality because the channel quality measurements are being sent to it. From these two measurements, it can know which is the best data to select, and that's called macro diversity. So that's the other function that the RNC performs, and that's another important reason why you have this IUR interface, because of the fact that the wideband CDMA allows something called soft handover. Okay, so basically in soft handover, you maintain connections with multiple base stations. Okay, and your connection is only the connection, any one connection. You might even be having 3 radio links to 3 different base stations. Okay, so the connection is only broken when that link becomes really poor. Or if for example you have 3 links and you discover that there is a 4th link now to a better base station, maybe the worst of the 3 is dropped, and you establish a connection with the new one with which you have a better connection. Okay, and this is all of these functions have to be performed by the UTRAN, because the UTRAN is in charge of all radio resources. Okay, the other thing that it also does is admission control. Okay, whenever a new request comes in, it checks the consequence. Okay, this particular user is requesting this type of data rate. Okay, what is the current situation? How many users do I have? What is their power requirements? If I add this user, how much will the power increase by? Will it cause the system to become unstable? So it does some kind of admission control. It does congestion control. It does handovers. It performs macro diversity. So all of these, on the previous slide, not the previous slide, the one before the previous slide, we saw all the important functions that the RNC has to perform. Now, this thing, apart from the uplink, it also happens on the downlink. Okay, on the downlink, the data that is going towards the mobile, if the data is coming from either from the circuit switch network or the packet switch network, the RNC, the SRNC, the serving RNC, transmits it down to the appropriate node Bs that are serving that particular mobile, and it also, if there's a drift RNC into which the mobile has drifted into, it also transmits the data to the RNCs and it goes back. So again, at the user end, the user is comparing the data that it is receiving on the downlink from different node Bs, and it is selecting the best one. Okay, so that's a quick introduction to node B and RNC. The next thing that we're going to look at is the core network. Okay, now in the core network, this is a very simplified diagram. The diagram that I drew for you earlier is a more complex diagram, but in this diagram we see that the core network has a circuit switch part to it and a packet switch part to it. The packet switch part essentially consists of an SGSN and a GGSN, but we know that there are also a number of other network elements that are also involved here. And the circuit switch part, in the circuit switch part, you have information traveling on the IUCS interface towards the MSC, and the MSC sends it on to the PSTN network. That's a very simplified diagram. This one is a more relevant diagram. So inside the core network, we have a circuit switch domain, which was inherited from the GSM network, and we have these shared databases. And then at the bottom here, you have the packet switch domain that is inherited from the GPRS world. Okay, so all of these network elements, SGSN, border gateway, charging gateway, GGSN, billing center, we've seen all of these in the diagram that we drew for question 1. Okay, again, a similar diagram. So between the UTRAN communicates with the packet switch domain as well as the circuit switch domain, and it has to create bearers or channels on which information is sent. So there is the IUPS bearers. There are both for carrying user data as well as control the control plane where all the control messages are sent. So what you have in blue here is the user plane. In both directions you have user plane and you also have a control plane. And similarly between the UTRAN and the user, you have, so these are referred to as IU bearers, okay, because they can either be IUPS or IUCS, and they can be either user or control plane. These bearers here are called radio bearers. They should be called UU bearers, strictly speaking, but they're referred to as radio bearers. And on these bearers, you have both user plane information, user traffic, as well as any signaling that needs to be sent between the UTRAN and the user equipment. So the functions that the core network performs, the three main functions are connection management, session management, and mobility management. Okay. Connection management is about connection management provides, I'm just going to read what's here. It provides the bearer services and procedures for circuit switch connections. Okay, so everything to do with what the circuit switch network has to perform, all of that is done with connection management. Session management is associated more with the packet switch network. Okay, so you have something like PDP context activation, PDP context deactivation, PDP context modification. All of these are session management procedures because they all have something to do with the setting up of, or the release, or the modification of packet switch connections between a user and the packet switch domain. The third category of functions is referred to as mobility management functions. Okay, so one of the important things that any mobile network, whether it be a GSM or GPRS or UMTS network, has to perform is mobility management. You have to be able to determine which cell or which location area or which routing area a user is located in, and that is done using a set of procedures called mobility management, essentially to do with managing the mobility of a user. Okay, the circuit switch domain. Okay, now here you see the term media gateway that I talked to you earlier about. Okay, in the circuit switch domain, the two main elements are the MSC and the media gateway. Okay, as I said, the media gateway essentially, whatever information is coming on in the form of ATM cells has to be converted into 64 kilobits per second time slot information. And that's the function, the main function that the ATM, that's the main function that the media gateway performs. Okay, you have a slide here that tells you about the 3G MSC and VLR. Okay, the MSC, remember what MSC, what is the function of the MSC in the GSM network? Do you remember? What does MSC do in the GSM network? What functions does it perform? Any ideas? What does MSC stand for? Mobile switching center. Okay, so what's the main function it performs? Switching. Yeah. Okay, it's a switching center. It essentially takes information from one time slot on one TDM input and puts it in another time slot in another TDM output. Okay, that's essentially the main function. That the switching function is an important function that the MSC performs. Okay, so it's the same MSC that we are dealing with, the same MSC that is more than 10 years old. Okay, most of the time. So it essentially performs switching in the time domain. What does a VLR do, by the way? Why do we have a VLR? Huh? Yeah, I know what I'm not asking you for what the abbreviation stands for, but the question is, what does the VLR do? Why is it there?
Data is information
Yeah. Okay. All of the subscribers that are located in the cells that are served by that MSC, their information, okay, is stored in the VLR. So VLR is a temporary database which stores information about subscribers, because you don't want to be continuously inquiring the HLR for information about users that are within your area. So it'll be much faster if you, whenever a user, because it's very unlikely that users will move out of an MSC coverage area, because an MSC coverage area will be a large area, maybe a large city or something like that. So once you have a subscriber within your MSC area, you want to keep their information in your database so that you can serve him much more quickly. Okay, so that's the main reason that you have. So a VLR is essentially keeping the visiting user's profile in your own database. Okay, so here, okay, now I told you about media gateway. So the media gateway performs three important functions. Okay, it does the conversion from ATM to TDM. It also has to convert the signaling. Remember, all of the signaling channels that are coming from the RNC will be based on ATM signaling. So all of these have to be converted from this narrowband to broadband common channel signaling number 7. Okay, so that's another function that the media gateway has to do on the signaling plane. And it's also got to do a little bit of transcoding. Okay, here's an example of a typical, when you start working in the industry, these are the sort of numbers you will see. Okay, for example, here is a Nokia MSC, and some of its specifications are it can handle about 600,000 busy hour capacity. It can handle 16,700 Erlangs. At maximum, it can handle 600,000 subscribers, plus 200 for telemetric services and so forth. So these are some typical specifications that you might have for an MSC, and these are some typical specifications that you might have for the media gateway. Okay, how many RNCs can this media gateway service? Okay, so this particular Nokia media gateway can serve up to 8 RNCs. Maybe an Ericsson media gateway could handle more RNCs. So when you are deciding what equipment you should buy as an operator, when you're looking at different vendors and trying to see whose equipment you should buy, you look at these kind of specs, okay, and you also look at the performance, and you also look at the cost to decide which particular media gateway and which particular MSC you're going to use. Okay, there's more information about how the HLR capacities are specified. Okay, so this particular Nokia HLR can handle up to about 1 million subscribers, and the EIR can, how many, in the EIR you can have blacklist, graylist, and whitelist. I think you would have studied about this in the GSM subject. So how many entries can you have in each one of these lists and so forth. Okay, we move on. We'll have a look at the core network. Okay, the core network is made up of the GGSN, SGSN, and so forth. The main network element is the SGSN. Okay, this is another way of drawing it. Okay, now you can see the diagram that you drew earlier. All of the network elements that you had on the previous diagram are here. So you had the SGSN, and the SGSN communicates with the BSC, and more particularly the packet control unit via the GB interface. It communicates with the MSC on the GS interface, communicates with the HLR on the GR, GF, GD, and so forth. So all of the interfaces that we talked about earlier when we drew that diagram are all on this diagram. Okay, so the main network elements are, apart from the SGSN, are the GGSN, border gateway, DNS, charging gateway, legal interception, legal or lawful interception gateway. Okay, so what we'll do now is go to question 2 on that sheet that I gave you. You should now be in a position to do question 2. We've been talking about release 99, which is also called release 3. The next release is release 4. So what's going to happen in release 4? Essentially, one of the things that's going to change in release 4 is that the MSC is going to be replaced by something called an MSC server or MSS. Okay, and so you're going to have something called an MSC server and a GMSC server or a GMS, and then your media gateway, you're going to have all of the data. Essentially what's going to happen is all of the user data is now not going to go through the MSC anymore. All of the user data is going to go via one circuit switch media gateway to another circuit switch media gateway out to the PSTN network. It's only the signaling messages, which are shown by the red dots here, that are sent to the MSC server. So remember, the MSC does two functions. It has to take the user data that's coming in and put it out on the appropriate external network or maybe within itself. And it also has to perform a lot of control functions. So there is a separation between the user plane and the data plane. So the user plane is this plane here that you see here. So all of the user data, whether it's coming from the UTRAN or from the GRAN, the user data will go straight through one media gateway, out through the next media gateway, and out to the PLMN network. It doesn't go through the MSC, either the MSC or the MSC server. Okay, so what the important thing with this is that we don't have to now convert from ATM down to TDM and so forth. Okay, depending on which type of PSTN network that you connect. If you're connecting to an external network that is capable of understanding ATM cells, then you can transmit directly on ATM to it. So we have a couple of new elements. We have an element called HSS, which is replaced the HLR that we had before. And then you have the media gateway, and you also have the MSC server and the GMSC server. Okay, so I told about this separation of functions, that all of the control functions, okay, such as interrogating of HLR to find information from it, signaling from one network to another network in the establishment of a call, okay, interacting with the circuit switch gateway for all of the charging related functions. Okay, CDR stands for charging data record. So all of those charging data record functions, all of the signaling functions are now going to be performed either by the MSC server or the GMSC server. All the circuit switch media gateway will do is to do everything with the user traffic. So bearer control, maybe changing the type, maybe setting up the bearer, tearing it down when the call is finished, converting the media from one form to another, processing of the user data packets, and those functions will continue to be performed by the media gateway. Okay, the main idea that they're moving this way is, the whole idea is this is an intermediate step so that eventually you can move towards a complete IP solution. And that's what's going to happen in release 5. In release 5, we will move towards a stage where the entire circuit switch network will be got rid of, and everything will be in the form of IP packets, and all of the information from the user will start from an IP packet, whether you're transmitting voice or whether you're transmitting data. All the information that a user is creating will be transmitted in the form of an IP packets, and then it will go through the SGSN, GGSN, and out to an external network. So that's what Release 5 is going to move towards. Okay, and some of the details of the Release 5 elements are also given in the slides. Okay, so the last couple of slides essentially give you a summary of the difference between Release 9, Release 4, Release 5, Release 6, and Release 7 are supposed to be coming in the future. So as we move to Release 5, we see that even the air interface technology is going to be changed from wideband CDMA to HSDPA, and further down the line some other changes are going to be made as well. Okay, so that's all that I want to tell you about